Hi everyone, this is our experiment 8, decomposition of hydrogen peroxide. And this is your lab handout. So what we're gonna need for this experiment, you need hydrogen peroxide, 3% hydrogen peroxide, that's what is commercially available. And you need potassium iodide, that's going to be our catalyst, a sidearm flask, 2 graduated cylinders, basket of water, 100 milliliter graduated cylinder, and a tube and a stand. So you will need a water bath. And now we are going to fill the 100 milliliter graduated cylinder with water. You're going to fill it up underwater and lift the graduated cylinder from the bottom, and don't lift it off of the water, but keeping the opening of the graduated cylinder underwater, you're gonna secure it into a clamp. Excuse me. You see now there are no air bubbles to begin with because you completely filled the graduated cylinder with water. Keep the opening of the graduated cylinder underwater. Secure with the clamp, and then you're gonna get the rubber tube and put the tube inside the graduated cylinder. And you take the Erlenmeyer flask. Actually, you're gonna take the sidearm flask, and then you put the rubber tube into the sidearm. You also need a stopper. So you're gonna get this set up first, and then you're gonna prepare your hydrogen peroxide sample, and we need 5 milliliters. So you're gonna take a 10 milliliter graduated cylinder and put 5 milliliters of hydrogen peroxide, zero the balance first, and then put the graduated cylinder with 5 milliliters of hydrogen peroxide and record the mass. And we are going to put this inside our sidearm flask. And then after you pour your hydrogen peroxide, you need to get the mass of the emptied graduated cylinder. Make sure to zero the balance and get the emptied graduated cylinder mass of that. Write it down. And then you need potassium iodide, 1 molar potassium iodide, 10 milliliters. You use a different 10 milliliter graduated cylinder to get your 10 milliliters of potassium iodide. That is going to be our catalyst for the decomposition of hydrogen peroxide. So as soon as you put your potassium iodide, you put the lid back and you're going to start swirling the flask. So you will see that in the presence of the potassium iodide, hydrogen peroxide decomposed to give you oxygen and water. So the oxygen is a gas, and then the water that's going to generate stays inside the flask, and the oxygen gas goes through the tube and going to collect over water inside the graduated cylinder. You can see that as the oxygen goes up, the water level goes down. So you're going to do this until you don't see any more oxygen coming from our reaction flask, or for 10 to 15 minutes. So in this experiment, what we are trying to find out is the percentage of hydrogen peroxide in commercially available hydrogen peroxide bottle. So we're going to find out the number of moles of oxygen that we generate. And how are we going to find the number of moles? And this is the experiment which is relevant to our gas laws. Remember, ideal gas law is PV equals nRT. So we can find the number of moles of oxygen if we know the pressure, the volume, the temperature, and which is the rest is the R, which is the gas constant. So volume of oxygen going to be, after 15 minutes, you're going to check to see how much oxygen has been collected. So since we are using a graduated cylinder, you can measure the amount by reading the mark. So we have about, I think, close to 40 milliliters collected. So you can measure it. And then we're also going to get the barometric pressure, which is going to be our total pressure. And you're going to put a thermometer inside the water bath and find out the temperature, because that would resemble the temperature of the oxygen gas that we collected.